Hey, Algebra, we're going to do the last section of Chapter 10. It's called Trigonometric Functions. Trigonometry, if you don't know, it comes from the word triangle. And in high school, you'll have almost a whole course on trigonometry. There's a lot to do with trigonometry. We're just going to dip a little bit of our toe in the water and just experience a little bit of what it's like. Trigonometry has to do with right triangles. Okay, so it only works with right triangles. We know that this is 90 degrees. And like the Pythagorean theorem says, you know that the hypotenuse is the longest side. And so let's just say this is like side A, side B, and the hypotenuse side C. What trigonometry says is that there's a relationship between the angles and the sides. Now, I could have a right triangle. Let's say this was a 3, 4, 5 right triangle that you learned about in the last section. A 3, 4, 5. Okay? Well, I could have a triangle that looked like that. I could double the size of everybody, make it 6, 8, 10. I don't know if you can see it, and maybe my drawing isn't perfectly accurate, but even though I double the size of everybody, the angles are still going to be exactly the same. They're proportional. So the angles will stay the same, and now I just have to tell you one side, and you're going to know how big the triangle is going to be, because everybody's going to be proportionate with that. Let's do this practically a little bit here. So I'll get rid of this, the A, B, and C, just so it's not confusing. Let's say this is a 3, 4, 5 triangle. There are three main, what do they call them, trigonometric functions that you're going to have to know. One is called sine. One is called cosine. And one is called tangent. And these are written for you on the very first page of 10-6. It's page 656. The sine is the first one they give you, and that is going to be the opposite over the hypotenuse. Now what they mean by that, let's say that I'm taking this angle here. We'll call it angle 1. Or, sorry, let's call it angle A, just so we don't get confused with all the numbers. So angle A here, what they mean by opposite is you go from that angle, we're not talking about the hypotenuse, we're looking opposite of that. There is the opposite side from that angle. So in this case, the opposite would be 3, the length is 3. And we put that over the hypotenuse, which is 5. So the sine for angle A is going to be a ratio of the opposite over the hypotenuse. And that it tells you the ratio of those two. Basically, what they're saying is the ratio of these two sides are related to that angle, and they can tell you what that angle is. If you just take 3 divided by 5, you're going to get 0.6, and the sine of angle A is 0.6. The cosine is going to be what's called the adjacent side divided by the hypotenuse. The adjacent side is the one right next to it. Now look, I know there's two sides that are next to angle A, but it's not the hypotenuse, it's the adjacent side here. So from angle A, this is opposite, this is adjacent, this is hypotenuse. So the cosine for angle A is going to be 4 divided by 5. And if you do that, it's going to be 0.8. The tangent is defined as the ratio of the opposite side over the adjacent. Opposite over the adjacent. And so opposite is 3, adjacent is 4. So in this case, it's going to be 3/4 or 0.75. So again, let me restate this. There's a relationship between the angles of a right triangle and the lengths of the sides. If you know one angle and one side, you can figure everybody else out. Now let's practice just for a moment. Let's call this angle B. What would be the cosine of angle B? So I'll stop. You think about it and come back with an answer. Okay? Angle B. What's the cosine of angle B? Now remember, cosine is the adjacent over the hypotenuse. So from angle B, what's the adjacent side? It's that. It's 3 over the hypotenuse, 5. So the cosine for angle B is 3/5. The tangent for angle B would be the opposite over the adjacent. It would be 4/3. The sine for angle B would be the opposite over the hypotenuse. In this case, it'd be 4/5. Okay, does that make sense? I hope it makes sense about how we're getting these relationships. Now, there's a quick mnemonic if you want to do it. I gotta say, I don't usually use this one. It's kind of cornball, but let me just tell it to you anyway. Here's a way to remember these. What does a mathematician do with an ingrown toenail? Well, he soaks a toa. Yep, he soaks a toa. Sine is the opposite over the hypotenuse. Cosine is adjacent over the hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. Yep, I told you, corny, but it might help you remember it. All right, so how would we use these things? Let's say that we knew angle A was, let's just say, 40 degrees. And I'm just going to make up a dimension. I'm going to say that this is 9 meters tall, let's say. And I'm going to ask you to figure out x. So you're going to have to use your fancy new math here, trigonometry, to figure out what x equals. I don't know if you remember this, but in astronomy, remember we did that one where we measured the distance to stars using parallax? You had a meter stick here. You had a straw here, you put it 90 degrees and you sighted down to your distant object. And then you went to the other side of the meter stick and you got a certain number of degrees. Basically, we were using trigonometry then, we just didn't call it trigonometry. So anyway, let's just practice. Let's figure out what x is. Well, so our angle is 40 degrees, and we want to figure out x. So we're going to have to use something that uses the adjacent side, right? We don't know the hypotenuse, so we don't want to do adjacent over hypotenuse. In this case, we're going to want to use tangent. Okay? So the tangent of 40 degrees, and remember tangent is opposite over adjacent. So it would be 9 over x. Does that make sense? That's how we set up the problem. So now let's solve for x. So if you take your calculator, just turn it on. I think you have to hit, on my calculator, I have to hit tan first, then 40, then equals, and it gives me 0.839. So I'm going to round that to 0.84. So the tangent of 40 degrees is 0.84 equals 9 over x. Now I'm hoping you know enough algebra that you can solve this just as easy as laying on the couch like you're doing right now. We want to get x by itself, so we're going to multiply by x. Basically, we're multiplying on this side and that side by x. X is going to go away. So we get 0.84x equals 9. And now we're going to move this 0.84 to the other side and divide by 0.84. And 9 divided by 0.84 equals 10.71. So x equals 10.71 meters in this case. Okay, do you understand how we solved it? Now, if x would have been the hypotenuse, we could have used another one. We wouldn't have used tangent this time. What would we have used? We would have used something that involves the hypotenuse. And since we only know the opposite side, I'm going to use sine. The sine of 40 degrees would have been 9 over x. Does that make sense? So using these things, you can solve what they call solving a triangle. You can figure out all the different angles and measure and lengths. Now, let me just show you a quick thing. Sometimes we don't know the number of degrees. And all that we know, let's say, is, let's just do this one backwards. Let's say this is 10.71. And we'll say that we don't know this angle. We're going to set up the problem just the same. The sine, oh no, it wasn't sine, was it? It was tangent. The tangent of x, remember, is the opposite over the adjacent. 9 over 10.71. Well, we already know, since we just did this one, how many degrees it is. But let me show you how, if you didn't know, what you would do. This is now the unknown. So there's a little button on your calculator that says the inverse of the tangent. Basically, it's like we're solving for the tangent of it, what it is. We know that the ratio is 9 divided by 10.71. But in this case, we're going to do, on mine, I'm going to look for the one that says tan. That means the inverse of the tangent. So for mine, here's what I'm going to have to do. Second, right above the tan, there's a little yellow tan -1. Sorry, I got to turn this on. Second, tan -1. And then I do 9 divided by 10.71 equals, and it gives me 40.04. But basically, if I wanted to round it, 40 degrees. And we already knew that from before, but it tells us that this would be 40 degrees. Okay? All right, I'm hoping that makes sense, because tomorrow you're going to come in and you are going to be real-life detectives. Actually, you'll be fictional detectives, but you're going to be detectives, and you're going to solve a cold case that happened here at Holy Rosary over 20 years ago. An attempted murder on someone that you know and love. Okay, I'll see you tomorrow. Bye.